This is integrated 1, and it is 7-10. We already did A, and we decided that it was a geometric sequence that was multiplying by a half. And so this is 7-10, letter B. And it says, assume this is a geometric sequence. Remember, the sequence was 40, 20, 10, 5. And it says, on graph paper, graph the sequence up to n equals 6. So this is n equals 1, 2, 3, 4. So I need to go 5 and 6. Because that's n, right? So, yeah, that's what you're probably getting confused about, because you need ordered pairs, right? So, what's this next term, everybody? I know it's hard, it's fraction math. It's whatever half of 5 is, right? 2.5, yeah, 2.5. And then, because remember, it's multiplying by half. So, and then half of 2.5 is, 1.25. Oh, thank you. It's 1.25. So we can use this little table right here in order to make a graph. And it's kind of sad because you have to have your graph, you're going to have to scale it because you're probably not going to have 40 spaces on your graph. So what would you like to, now we don't need the negative part of our graph, so at least that's maybe some good news. But, so I'm going to make my graph, and I have to decide, I think I'd like to count by ones down here, because these are actually, look, these can be the x's and the y's, if you will, or the n's and, actually I should have said these are n's and t's of n, t of n, right? So, does anybody have an idea? I would like to count by ones down here, because I just have to go up to 5 or 6. Does anyone have a scaling idea for me? For the y-axis? Or the t of n, I'll do it correctly, the t of n axis, and this can be the n axis. We can count by 5s or 10s or 20s or... 10s? And count by 10s, that's pretty good, yeah, let's count by 10s. So let's go, you know, and since I have all this room, I'm going to count by 10s, but like this. 10, 20, 30. I don't want to spend too much time planning. I probably could have done a better job than that. Actually, my graphing calculator, I could have done a way better job than that, right? But that would fit on your paper if you did something like that. Okay, so then I have to graph 1, 40. So here's 1. Let's make it green. 1, 40. And then 2, 20. And then 3, 10. And then 4, 5, 2.5. So I guess that'd be right there. 6, 1.25. So it's going down like that. And, you know, we could debate, well, we don't really probably want to connect it with a smooth curve because we don't really know what the situation is with this one. It's a sequence, actually, so we don't want to connect it. Will the values, so that's letter B. Is there any questions on that? Okay, and then letter C says, will the values of the sequence ever become 0 or negative? What do you guys think? Huh? Yeah, for B we just have, oh, no, sorry, that's, okay, well no, this is B. That's B, but then for C, isn't that all? Yeah, it says assume this is geometric. On graph paper, graph the sequence up to n equals 6. So that has satisfied what they asked for in letter B. So for letter C, I need to write some little answer to their question. So they have asked me, what will the values of the sequence ever become 0 or negative? What do you guys think?
No.
No? Why not? So we'll say no because what?
Oh yeah. Because it's just decreasing by half, it'll never reach below zero because eventually it's just gonna reach like say 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and so on and so forth until you get like 1.
Yeah, it'll get infinitely small, and it'll never, it's kind of like when I told you guys the story about how technically I should never be able to get out that door, because if I keep taking the distance, like if I split 1.25 in half, it's just going to be smaller, but it's still going to be a positive decimal. And then if I split that answer in half, you know, you can keep doing it on your calculator. You can go, look, 1.25, divide by 2. You get that thing, right? And then you can divide it by 2. And you can do that all day long. And you will never get to 0. You'll get to 0.000000000, and then some numbers behind it. But you will never get to 0. And if this were a smooth curve, it would have what we call an asymptote right here on the x-axis or the n-axis. Oops, right there. But we haven't talked about that yet.
The biggest calculated decimal ever was that